All right, so we're going to move on to lesson 2 in unit 6 or 6.2, which is going to deal with ionic and covalent bondings. So atoms bond when their valence electrons interact. Remember and remind yourself what a valence electron is. A valence electron are the electrons located in the outermost energy level. Generally, atoms join to form bonds so that each atom has a stable electron configuration or 8 in its outer shell. The octet rule or the rule of 8. Remember, all atoms on the periodic table, with the exception of noble gases and some noble metals, want to become stable. They want to become full. They don't want to be reactive. And the way they achieve this goal is by creating bonds. So bonds can bend and stretch without breaking. Two important vocab terms, an anion and a cation. An anion is an ion that has a negative charge. Once it gives up or gains electrons, it's going to have a negative charge, typically means it's going to gain electrons. Cations are an ion that has a positive charge, so this is an atom that becomes an ion that gives up electrons, which means it's going to have a positive charge, calling it a cation. So naming ionic compounds. In many cases, the name of the cation is just like the name of the element from which it is made. So when an atom of sodium, which is Na, loses an electron, it becomes a sodium ion or Na+. Now remember, and think about this, the plus charge comes from the number of protons in comparison to the number of electrons. Okay, so on the periodic table, the atomic number tells us the number of protons and the number of electrons. But in ionic compounds, some atoms are giving up electrons, other atoms are gaining electrons. Okay, so sodium, for instance, is giving up one electron, which means it's going to have one more proton than it does electron, excuse me, which is going to give it an overall charge of +1. So sodium plus. When the calcium atom loses 2 electrons, it becomes Ca2+. So again, if you go to the periodic table and you look, Ca has a certain number of protons, a certain number of electrons. If it gives up 2 electrons, it has 2 more protons than it does electrons, which is going to give it a +2 charge. So ions of group 1 elements have a +1 charge. Ions of group 2 elements are going to have a +2 charge. And names of anions are altered names of elements. Okay, so the cations are going to be, again, typically the name of the atom on the periodic table. Sodium is going to be sodium, whether it's an ion or not. Anions could change. So just like cations, anions of elements in the same group of the periodic table have the same charge. Typically with anions, we drop the suffix and add IDE. NaF is made up of sodium ions, Na+, and fluoride ions, which are F-. Therefore, the name is sodium fluoride. So fluorine on the periodic table is going to accept electrons, become an anion. We drop the INE and add IDE, fluoride, sodium fluoride. Some cations' names must show their charge, so considered iron oxide and iron oxide. Okay, with the name, you see there's no difference. But if we look at the numbers of the atom, the amount of atoms in the compound, there's a big difference. So by rules, we just learned both would be iron oxide, right? Okay, iron is the one giving up electrons. Oxygen is the one that's accepting electrons. So iron is going to be the cation. Oxygen is going to be the anion. So by rule, it's iron oxide. Okay, oxygen, drop the suffix, add IDE. They can't have the same name because they're different compounds. There's a big difference between FeO and Fe2O3. Okay, so FeO is a black powder and Fe2O3 is a rust. So they don't even produce the same thing. So some of the transition metals can form different charges, and this is where it gets tricky. We have to look at the anions to see what the anion needs to like to make before we can name the transition metal. So in these cases, a Roman numeral must follow the element. So Fe2O3 would be iron 3 oxide. Okay. FeO is going to be iron 2 oxide. The Roman numeral indicates the charge on iron. Right? So ionic bonding. Okay, polyatomic ions act just like any other negative ion when bonding. So sodium, okay, is going to have one electron to give up. SO4 is a polyatomic ion. I'm going to give you a polyatomic ion cheat sheet, okay? So sodium 2 or sodium sulfate, and then aluminum nitrate. Okay, so I'm going to give you a polyatomic ion, which are these predetermined compounds. Oops, didn't mean to do that. Cheat sheet when we start working on creating ionic compounds. Okay, be sure you complete the video form that goes with this, and let me know if you have any questions. Thank you.